Hello, welcome back to Brand Sushi LIVENODING. In this episode, I will be telling you a story about how you can save and load a sequence of weight paint or weight map. So you can see here already, this is like a reaction diffusion weight map that you can generate using a tissue add-on. And currently it's actually still running, but I stop it. And the idea is to be able to save the animations that generates these reaction diffusions. Let me show you once again. If I delete all the weight and I'm gonna stop reaction diffusions and gonna start again, but I'll give this like 15 maybe and start the reaction diffusion. This guy should be changing if I actually paint something. So you have two weight, A and B. So maybe we're gonna work on the B. So yeah, this is basically just a flat plane that I subdivided 6 times. So we can generate a starting weight. Maybe that should be interesting enough. And then play maybe frame by frame. Start reaction diffusion. So there you go. Oh, that's the magenta one. When that's happening, that's not very good. Let's stop it again. So let's start reaction diffusions and just make it 10. This one radius 25, and let's draw something. Hopefully this works. Okay, so that's reaction diffusion, and you can see how the weight is changing for each frame. And I want to be able to save that. And how did I do it? Actually, this is the way that's actually makes sense for me. I'm actually using Sphere Chalk add-on to save the weight. You can of course do this using Python as well, and then using Python that's kind of triggered whenever you update a frame. But the nice thing, actually, Sphere Chalk already have it. It's called the vertex group weight. So this node can take in and take out the value of weight. Currently, this is observing weight called weight B. So because with reaction diffusion, you actually have two value, A and B, right? And I'm just looking at the B, and then I'm dumping this weight value into this guy over here. So this is the text. This is actually text file that's containing all the data value of the weight, and this is actually updated on the fly. So you can see up here there's like over 4,000 values because we have over 4,000 vertices. Of course, this is for every single vertices, and yeah, it's saving it. And then let's see how far it's gonna go. I think it's gonna settle at around, so it's keep going. Yeah, I think 100 or 150. Let's call it like that. So yeah, there's with a little bit of Python. Here I'm actually using this execute node mode. This one is actually a very cool node. So you can basically, instead of using script node, this is actually so much easier and simpler. It's like a script node. You can put some data, whether it's like a list of data or just a single data, and then here my input is actually just the current frame, and the output is actually a text file. So for each frame, it's gonna grab this data from here, from this text, the main file, and then dump it and save it out as a text file. And I have it already over here. So this is, I think, the text. Currently it seems to be not showing everything, but if I go to Sublime Text and then open it, there's a text out, and here we have all the text. So yeah, let me actually run it for the whole 150 once again. I should have Maybe I should have deleted it and then run it again. So delete this folder, create another folder, call it text out, and let's start again and then rerun the simulations. Stop reaction diffusion, delete everything, start painting once again. And before I run it, you might notice that this is just a single value, right? You can actually do like something a little bit crazy, like vector in and then plug this into the y or into the x, for example. No, into the z, and then use range float and list length, plug into this guy, and this guy goes into the count, this goes into the x, and then use UV connections. So what's gonna happen is that it's gonna generate some kind of geometry over here that you can actually export out as Alembic. Yeah, so it's seems to be calculating. Maybe I shouldn't have done that. I think I might have made a mistake here with the list length. Oh well. Okay. Maybe this should be 1. Okay. Bmesh, fewer bmesh, or just a fewer row. Okay. So that's the result. Just the age. Okay, so what's going on here? This is the line that represents for every point's weight of this mesh. So when I actually run this text out is going to be filled out with text, and this is also going to be generated, and you can see this is the reaction diffusions kind of happening, and this text file also being generated. It doesn't update because I'm using the beta version. Well, it should update. Anyhow, let's wait for maybe 100 frames. So it settles at around 100. So we get this green. I think it's still keep going actually, but I'm just gonna stop it at around 100. So we're gonna end up with 100 text files, each one of them representing the value of the points of the weight of each point. So this is actually a geometry. In the past, actually, I've been using this method to save out Alembic. So with that Alembic, you have this data, like an animated sequence of data that's you can visualize, but you can also reuse. You can easily import Alembic, right? So with this data, what you're gonna do about it? So look at this. So look at this value. You can simply bring it into another blend, and then you will start with the same mesh, and you simply pipe down the weight. So I'll show you the result of this is how you can load it. So this is one example. This is where all the text file has been loaded into memory, into blend. So here I have 20 text only. And this is the node tree that's actually loading the weight and reassign it into the mesh. So this way we can really do a lot. So let's take a look. So this is our plane objects, and this is the vertex group weight. Once again, this one is getting the weight from the text. So this is the Python running as nodes. Yeah, it seems complicated, but it's not really. So basically it gets all the text and then filter the text that's named text underscore, and then for every frame updates, get the lines, get the body of the text, and then for each text, just use AST as literal, and then get the data, pipe it into this mapping, range mapping, so we can actually map the range as well. So you can see it's updating in real time. And yeah, you can get the weight back. One thing to know is that so let's say I have this is from the file over there. Let me try actually grabbing 5, the drag and drop. No, maybe I will load it using Python script to just load it properly. So in Blender, right, there's one thing you need to know with the text file. If you want to drag and drop many files, you cannot do that. So you drag 6 files, it's only loading 1. So you need to drag and drop one by one. Or you can use script and just tell it to load all the files inside the folder and just bring it into memory. So this is actually, yeah, seems to be working. I'm trying to do the same in here. Let's save it first as a new version. So a bit of knowledge of Python is always really quite helpful. So this is gonna grab all the text file, load. Okay, I think we have all the files in the memory. So blah file, that's the name of the file. So I'm gonna specify here blah file. Hopefully this works. Oh, there is no underscore. Cool. Okay, so it says there's 100. So yeah, you can see I think this is working. This is actually from the other file. So that's the simulations. We actually have more. So 100 frame, right? So this is what's we happening. Oh, this is how I started. You know, my random doodle, and then reaction diffusion happens, and then it's starting to settle. Each one will get its own space, and then it's almost like an island. It's kind of growing, and this is what we end up with. It's really interesting to be able to visualize it like this. And now with this, of course, you can just file export as Alembic, but you can see the whole process now. To save and to load the weight of a mesh. That's with the help of Tissue add-on and also Spherechalk add-on. I managed to do this with a very short Python. So if you know, like, really good with Python, of course you can do a lot more with just text, but having it as a node really help, especially with me. I think it helps a lot to understand the process. So there you go. So to summarize, basically we started with this animated weight reaction diffusions using Tissue add-on, and then we are exporting the weight for every frame as a text file, and then in a different file we reload all these texts, and then reload every data and then update it for every frames, and then this is what we end up with. Alright, so hopefully this is useful. Let me know what you think. I'll provide all the files into GitHub, and hopefully this is useful for us, and I'll see you next time. Thank you. Bye.